Hi guys, we are on Unit 3, Day 4 notes. So the title for today, the topic for today is GCF and difference of squares. We're going to start with the top section here, which is greatest common factor, which stands for GCF. So just a little background here, kind of a little reminder. You did do this in Algebra 1. You've probably done it a few times already in class, but just a reminder, the greatest common factor can be a number, a variable, or both. And I'll show you, we're going to do a bunch of different examples where it's just a number, then it's just a variable, and then sometimes you can take out both things. So problem 1, 3x squared plus 9x. If you want to imagine this, and some of you this might not help, but I have the 3 in the front, and then x squared means I have two x's in a row, and I have plus 9, and then I have a single x. So I want to look at this problem. I want to find the GCF. I want to take out a number. So the number that I could take out of each of these would be 3. So I know a lot of you like to think like, okay, I'm going to divide both of these by 3. So I'm going to take out a 3. And then you also have to think about a variable. So I notice that they each have an x, and I'm highlighting those x's. They each have an x, so I'm going to take out the x. So if I'm going to, let me just write this down. If I'm going to divide by 3, 3 goes into 3 one time. I took out an x, so I have one x left, and then I have a plus sign. And then on the other side, 3 goes into 9 3 times. I took that x away, so then I can close it up. Okay, for my next one, I want to see what number can go into all three pieces. It has to go into all of them, or maybe what variable can go into all of these. I noticed that not all of the pieces have a variable, so I'm just going to worry about a number. And I noticed that 6 goes into all of these. So I'm going to take the 6 on the outside, figure out what I have left. 6 goes into 6 once with x squared. 6 goes into 18 3 times with an x. And 6 goes into 12 2 times. And that is my greatest common factor. Okay, the one next to it, 3x cubed minus 9x squared plus 3x. I notice that every single piece has an x, and I notice that 3 can be taken out of each of these. So I'm going to take out a 3x from all the pieces. So when I do this, 3x is coming on the outside. I'm going to figure out what I have left. 3 goes into 3 one time. I had 3 x's, but I'm taking one of them away, so it'll leave me with 2 left over. 3 goes into -9, -3 times. I had 2 x's. I took 1 away, so that leaves me with 1. Then 3 goes into +3 one time. X, taking that x out, and then I can close it up. Okay, the one below, 10x squared plus 4x plus 2. Not all of the pieces have x's, so I'm just going to focus on taking out a number. I could take a 2 out of every single piece. So let's figure out what we have left. On the inside, we have 5x squared plus 2x plus 1. And there is my greatest common factor. My next one, I want to find a number, variable, maybe it's both. I notice that they don't all have variables, so I'm just going to take out a number. Again, in this one, the largest, greatest number to take out is 2. That leaves me with x squared plus 2x minus 3 for the inside there. This last one, I notice that they all have x's, so I'm going to take out an x from all of these pieces, and I notice that 2 can also come out of all of these pieces, so it's kind of like I'm dividing by 2x. 2 goes into 2 one time. I had 3 x's. I'm taking 1 away. That'll leave me with 2 left over. 2 goes into 4 2 times with an x left over. 2 goes into 2 one time with no x's left over. Okay, so that was just a quick practice refresher on GCF. You did a lot of that in Algebra 1, so hopefully that is coming back to you. Okay, this next part, difference of squares. All I'm going to say here is I'm going to just write pattern, because eventually you're going to see a pattern with greatest common factors. But before we do that, I want to talk about what are perfect squares. You've seen perfect squares before. You've talked about perfect squares before. Let's just write them out. Okay, so I'm going to do this fairly quickly. I know not all of you have your calculator, so that's why I'm writing these all out. You're going to need to know these. Basically, have these memorized. They should be very familiar to you. 1 squared is 1. And if I wrote that as a square root, the square root of 1 is equal to 1. That's a perfect square. 2 squared is equal to 4. If I took the square root of 4, it would perfectly give me 2. 3 squared is 9. If I took the square root of 9, it would perfectly get me back to 3. 4 squared is 16. If I took the square root of 16, it would get me perfectly to 4. These are perfect squares so far. It only happens for certain numbers. 5 squared is equal to 25. The square root of 25 gets you right back to 5. That works out perfectly. 6 squared is equal to 36. The square root of 36 is equal to 6. Okay, I'm going to go a little bit more. 7 squared is equal to 49. The square root of 49 gets you to 7. X squared is equal to 64. The square root of 64 gets you back to 8. Hopefully you can see the pattern going. I'm going to do a few more. 9 squared is 81. The square root of 81 gets you to 9. 10 squared is equal to 100. The square root of 100 gets you back to 10. 11 squared is equal to 121. The square root of 121 gets you back to 11. And our last one, 12 squared is equal to 144. The square root of 144 gets you right back to 12. These are all super important. You're going to need to know these, okay? Most of those should look familiar to you once we got a little bit bigger with the numbers. I know you maybe haven't seen all of those yet, but hopefully after a while you'll see these over and over again. You'll get the hang of it. Okay, factoring the following completely. So here's what you need to know, and I'm going to make a little list up here. Let's do it in orange pen. Number 1, if you're doing difference of squares, there's going to be 2 terms. So instead of 3 terms, a trinomial, you're going to have a binomial, 2 terms. If it has 2 terms, you're going to want to look for must have a negative. You're going to look for the negative sign. And then the other thing you're going to look for is perfect square. So these are the 2 things I need to identify before I move on. So if I look at problem 1, it is a binomial. It has 2 terms. It has a negative sign, so that's good. And then I want to make sure the numbers are perfect squares. So in this case, there's a 1 in front. The square root of 1 is 1, good. And then there's a 25. The square root of 25 is 5, also good. So if they have the negative and they have a perfect square, I'm going to factor it into my 2 factors, and it's very simple. I'm going to split up x squared into x and x, and then the square root of 25 is 5, so each parenthesis is going to get a 5. And then for a difference of squares, when this situation happens, one of these is going to be a positive and one of them is going to be a negative. So see how they look exactly the same, except for one of the parentheses is plus and one of the parentheses is minus. So now look at problem 2. It is a binomial. It has a plus sign. That's no good. It must have a negative. So if it has a plus sign, automatically I'm going to say this is not factorable. Every once in a while, it's a little rare, but every once in a while this happens. Okay, the next one, 2x squared minus 200. Okay, it is a binomial. It does have a minus sign, but they're not perfect squares. 2 is not a perfect square. 200 is not a perfect square. So I'm going to see if I can kind of mess with this by taking out a GCF. I noticed I could take out 2, which leaves me with x squared minus 100. And then when I do that, I notice, okay, now I can maybe factor this new piece, and I'm just doing that in an underline there. I can go ahead and say, is there a minus? Yep. Is 1 a perfect square? Yes. Is 100 a perfect square? Yes. So this 2 drops down, and I'm going to go ahead and factor this. So I separate x and x. The square root of 100 is 10, so I put 10 in each of those. They look the same so far, except for one of them is going to be a plus, and the other is going to be a minus. Okay, keep going, just running with a ton of examples. This next one, x squared minus 81. It has a minus sign. 1 is a perfect square and 81 is a perfect square. So that means I can go ahead and separate it into my parentheses. Separate x squared into x and x. Square root of 81 is 9, so I put my 9s in there. One of them needs to be plus, and one of them needs to be minus. And that's it. All right, this next one, 3x squared minus 27. It is a binomial. It does have a minus sign. However, 3 is not a perfect square and 27 is not a perfect square. So I noticed I could take out a GCF. So I'm going to take out a 3. Let's see what we got left. 3 goes into 3 one time. 3 goes into 27 negative 9 times. And then I'm going to see, okay, now can I factor difference of squares, this new piece? Square root of 1, that's perfect square, that's good. And the square root of 9, that works out perfectly. Okay, so let's break this apart. Drop down that 3 from the beginning, separate out x squared into x and x. The square root of 9 we did on the side is 3, so each of those are going to get a 3. One of them is positive, one of them is negative. And like I said in the very beginning, it really is kind of this pattern. You're going to pick up on those perfect squares. It's a pattern. Number 6, x squared minus 16. It is a binomial. It has a minus sign. The square root of 1 is a perfect square. The square root of 16 is a perfect square. So let's go ahead and separate this. X and x. The square root of 16 is 4, so put your 4s in there. One of them is positive, one of them is negative. And then that's it. Just a few more. X to the third minus 1x. All right, this is a binomial. I agree with that, and it does have a minus sign. Okay, except for all the problems we've done so far needs to be an x squared. So we need to get this cubed out of here. So I'm going to take out a GCF of x. So I'm pulling out an x, which is going to leave me with x squared minus 1. And then just like the other ones, I'm going to see if I can factor this down any further. 1 is a perfect square, so that's good. It has a minus sign. This is all looking good. Don't forget about the x in the beginning. I separate x squared. The square root of 1 is just 1, so I put in my 1s there. One of them is positive, one of them is negative. And that actually worked out. This next one, I'm going to take out a GCF of 5. So I'm going to pull out 5 from both of these. That's going to leave me with x squared minus 25. And then I'm going to see if I could factor difference of squares, this other part here. 1 is a perfect square, so that's good. And 25 is a perfect square. And it has the minus sign, so this is all looking good. Make my parentheses. Split up x squared into x and x. Put your 5s in there. One of them is positive, one of them is negative. And then my very last one, x to the third minus 64x. Again, I need to have x squared, so I need to take out an x. So I'm taking out a GCF. I'm going to pull out an x. That's going to leave me with x squared minus 64. Let's see if we can break this down. I'm going to see if I could factor that part. Square root of 1 is 1. That works. The square root of 64 is 8. So these are perfect squares, and it has the minus. So this is all good. I just need to write my factors. 64, the square root of 64 is 8. So each parenthesis needs 8 in there. One of them needs a plus and one of them needs a minus. And then that would be it for number 9. Again, make sure you're looking on your Canvas page to determine if you have an exit slip or discussion board that you need to do for today.